The couple M is applied to a beam of the cross-section oriented as shown. Determine A, the angle that the neutral axis forms with the horizontal, and B, the maximum tensile stress in the beam. So let's say this is our coordinate axis system. So this is going to be my Y, and this is going to be my positive Z, okay? And then we have our moment, right? So we have 20 degrees here. So we can decompose this moment like this. And so we're going to have 15 cosine of 20 degrees and 15 sine of 20 degrees. But let's go in order. The first thing I like to do is realize what we're going to be using to find the maximum. Well, the first thing to determine the angle that the neutral axis forms with the horizontal, where the horizontal is this moment vector. Well, we can use this formula, tangent of phi, which really comes from the formula for unsymmetric bending by setting the stress equal to 0, because that's what the neutral axis is where the stress is equal to 0. It's going to be tangent of phi equals Iz over Iy times the tangent of theta. So phi is going to be the tangent inverse of Iz over Iy times the tangent of theta. Now I think that theta is with respect to the z-axis. So you got to remember that's going to be 90 minus 20. So that's going to be 70 degrees. So theta is 70 degrees. What about Iz? What about Iz? Well, they give you the type of cross-section. So what you need to do is you need to go to the appendix of the book, which is, I believe, Appendix E. And then you want to go to the particular cross-section that they mentioned, which is S6 times 12.5. So let me go over there. Still at W, S6 times 12.5. And what you want to do for that is you want to look let me see, S6 times 12.5. You want to look at how the graph looks. So my Ix in the book is going to be my Iz. So I'm going to be looking at that. And my Ix is 22.0. So Iz is 22.0, and then we check the units, inches to the fourth. And then my Iy is the same as the book, is going to be 1.8 inches to the fourth. So now we have everything we need to use this equation. So phi is equal to the tangent inverse of 22 over 1.8 times the tangent of 70 degrees. Now make sure that your calculator is in degrees. And then we do the tangent inverse of 22 divided by 1.8 times the tangent of 70 degrees is 88.3 degrees. Okay. And now that we have 88.3 degrees, what we're going to do is we're going to recognize what that is, 88.3 degrees. So that's like this angle right here. So this is my neutral axis. So what was the question? What angle does that make with the horizontal? Well, it's going to be this angle right here because we said the moment vector is the horizontal. So we do 88. So the answer, call it, I don't know, gamma, is equal to 88.3 degrees minus 70 degrees, which is 18.3 degrees. And that's the answer to part A. the answer to part A. And now we want to do part B. So to do part B, we want to find the maximum tensile stress. So let's do our usual procedure. So let's recognize that the stress is going to be composed of an mzy over iz and an myz over iy. And so what do we need? Well, we already have iz and iy. mz and my, we kind of have to figure these out. So mz is going to be what? Along the z is going to be 15 sine 20, and it's going to be positive. So 15 sine 20. And then my is going to be 15 cosine 20. So let's get that out of the way real quick. 15 times the sine 20, that's 5.13. And the units are kilopounds times inches. And then 15 times the cosine 20, that's 14.1 kip inches. Okay. And now that we have that, all we need to find is the different distances. So we have A, B, E, and D. So along the z-axis, ZA and ZB are the same, and they're negative, and they go half of 3.33. So 3.33 divided by 2 inches. Then we see that ZE and ZD are the same. So ZD is equal to ZE, and they're the same thing but positive. So those are negative, my bad. And then we do the same for the Y. Now the Y, A and E are the same. So YA is equal to YE, and they are a 6 divided by 2. So 3 inches in the positive. And so we'll see YB is equal to YD, and it's negative 3 inches. And so now that we have this, we can say sigma at A is going to be equal to minus mz 5.13 times y at A, 3 divided by I z, which is 22, plus 1.8 here, 14.1, and now we need the z for A, which is negative 3.33 divided by 2. And then we'll have something similar for everything else. So I'm going to copy this and paste it for the second case, for the third case, and for the fourth and last case. So we put all of these in, and now what do? Well, now we got to change some things. So for example, we know that Y, this is B, D, and E. So based on that, the YB is negative 3. So here we need a negative. The ZB is good. Now for D, the YD is negative 3. And the ZD is positive here. And then we have for E, the YE is 3, and the ZE is positive here. All right, so now we put it into the calculator, and what do we see? Well, we're going to see a couple things. Well, no. We're going to see minus 5.13 times negative 3 divided by 22. I don't know why I'm reading the last one, so I'm going with the last one first. 14.1 times 3.33 over 2 and 1.8. So I get 13.74. And then you got to figure out, okay, well, we had, for the moments, what were the units? The units for the moments are kilopounds times inches. These are inches to the fourth, and this is inches. So what we get is kilopounds over inches squared, which is KSI. So KSI tension because it's positive. Now we do a similar thing, but we got to change some things, like the signs. Here, it looks like, and let me see. So it looks like, I wonder if I made a mistake by doing it super fast. With the Y's, in my calculator, I inputted something incorrectly. I inputted something incorrectly in my calculator here, because my YE is positive 3. As you see, E is in the positive, and my moment is positive, but my E in the Z is also positive. Okay. So really I get something different. I don't want it. So I put a minus in front of the 3. I was not supposed to. And so we get 12.34 here. And then for D, I'm going to get, for D, I'm going to get 13.74. And then for B, this is all a sign game. I'm going to have a minus here and a plus here. I get minus 12.34. And that's going to be, compression. And then the last one is going to be 5.3, the same thing, but we're going to have a negative here, and we're going to have a positive here. So positive here and a negative there. And that's going to give me another, I did something wrong. Oh, we're going to have a negative there. So I'm going to take this, copy, paste it, and we're going to have a negative here. Minus 13.74 KSI. This is going to be in compression. So what is the max tensile stress in the beam? The maximum tensile stress in the beam is this one at point D.